Now we can look at adding our range detection. So we want to make some decisions based on how far away our target is from our MPC. So we're going to need a couple of variables to use as a reference for our range or our distance. So let's start by adding those. I have a minimum range. Make it nice and close just for an example. We're going to have a maximum range. Give it a good detection, good area field of detection. Okay, before I move on, there's something I want to explain about calculating the distance between vectors. Okay, so even if we jump over to the Unity scripting reference, we'll type in distance. Okay, we're dealing with vector 3's, so we have a vector 3 distance here. Now it's saying here, this inbuilt function is the same as asking for a magnitude between two vectors. So let's search that up as well. So currently, the Unity scripting reference has shown us two ways of calculating a distance. So these two lines do exactly the same thing as the Unity scripting reference tells us. Okay, let's cross-reference that. Vector 3 distance, AB, is the same as A minus B dot magnitude. Now this is actually a little bit processor heavy, it's a little bit intensive to calculate a distance like this. If we go over to the vector 3 magnitude, we see a mention of square magnitude. Calculating squared magnitude instead of magnitude is much faster. Okay? So how can we utilize this instead of just using our distance or magnitude? So our distance squared would be that. So if we have, in our example, we have our minimum range. Let's keep it simple. Our range is our distance. If we want to compare that to a squared distance, we can quite simply square our value. And I've typed all that in backwards. So probably okay, so if we have a minimum distance, if we want the square of that, we simply times it by ourselves. So let's set up some variables that will store our squared values. We'll make these private because it's nothing that we're going to be changing. We're going to calculate this and then use that in our functions and equations later on. So we don't even have to assign any values here. So in our start function, as I said, if we want our square minimum and maximum ranges, we'll simply calculate them by multiplying our ranges by themselves. And there we have it. Just by simply doing some calculations at the start, later on when we're checking distances, instead of using these normal conventions here, one of these two, just use a much faster method, a square magnitude, and compare it against our squared distance. Give you exactly the same result, but faster. So how are we going to implement this into our MPC so our MPC can start assessing the scene and making some decisions for itself? So we want to calculate our current distance, our current squared distance from the target. And this will be, as in my example, the square magnitude. And what's the distance we're calculating? That's going to be the difference between our target position and our position. So now we have our current square distance from our target. Let's see if we can make some calculations based on that. And then change our state. So if our square distance is greater than our maximum range, let's just set the state to free roaming. Actually, just jumped one step ahead of myself. This MPC is going to be working, it's going to have a possibility of two different behaviors. So let's create a boolean so we can set in our boolean if this MPC is going to be chasing or running away. So var is MPC chasing, to be a boolean, and I'll just set it to a default of true. And I always spell that wrong, don't I? So now when we do our distance check, let's just check that boolean. Okay, so if we are set to chasing, then even if we're outside our range, like in the case of Slender, he does always come towards you. So if he's a chasing type, no matter if he's not within the minimum range, we're going to set him to chasing. Else, if he's a running away MPC, he's not in a range. He won't feel like he's in a danger zone. So let's set him to free roam. Now we've done a big check on our range here. If it's greater than our maximum, what are we going to do if he's within range? So, if our square distance is less than our minimum square distance, we're going to do the same kind of checks that we've done here. We're going to see what type of enemy we're dealing with and set up some different states based on that. So in the case of Slender, if he's chasing but he's within the chase zone within a minimum range, we're going to stop him from moving. We're just going to leave him at idle, so he does not move, but he's still going to look at us. Now, if the enemy is not a chasing type and it is too close to our target, he's going to want to run away. Telesense is working. Okay, so that takes care of two conditions. If the NPC is outside of our maximum range, and if our NPC is less than our minimum range. Now what happens if he's in between? Let's set up a final conditional check for that. And then of course, we're going to have to set up some states based on what type of enemy we're dealing with. So if the NPC is chasing, we're going to have to do more checks for the slender guy to see if it's visible. And without adding all that stuff now, let's try and get this working. If he's in that middle range, we're still going to set him to chasing, just for now. Of course, before we do this finally, we're going to have to check if it's visible or not, so we don't see him moving. Now for running away state, we could say if our running away, if he's within our minimum and maximum range, he's still going to think he's too close. So let's get him to running away here too. There's a lot of stuff happening here. This would be a lot cleaner if this was in its own function. But I'm just going to plow ahead for now. Like I said, I just want to finish off this series and see how it goes. So first I'm just going to quickly check there's no compilation errors. So we have an enemy. And then with his chasing, he's going to check. If he's within this range, he's going to start chasing us. If he's outside 45. Okay, so he's within 45 there. Set him to running away. I can't change the state. I have to change the condition of our NPC. Let's get him. There we go. So he's too close to us. He doesn't like being close to us. So he's running away. Let's see what happens when he gets to the 45. Is that too far away? Yep, that's too far away. Let's just bring this down to 20 for testing. Let's try that again. So currently he's a chasing type. Let's move our player, see if we can get past the 20. Okay, that's quite a large value, isn't it? So if he's a chasing type, oh that's right, no matter if he's outside the zone, he's always going to come chasing. That's why that's happening. Alright, so that's normal expected behavior. It's what we programmed in. Okay, let's set him to running away. So he's going to start running away. When he gets past that distance of 10, he's on free roam. I think what's happening there is because we've set the desired velocity. So even though we're not making any more calculations on changing our rotation or anything like that, he's going to maintain his velocity. So we can check this here. Where's our desired velocity? Let's just type in. Will equal new vector 3. I'm just going to set this default to 0. And then our rigid body. Velocity y. And 0 on our z. Okay, so now if he's in free roam, once he gets out of our range, he should set his velocity to 0, unless he's falling, so we'll maintain the y. Currently into a chasing type. Set into a scared type. There we go. As you see, as he passed our maximum range distance, he's changed his state to a free roam, and in our free roam we have just set the velocity to 0, so he stopped moving finally. So that we can see that working and in action. Now similarly, for the idle state, as our guy got too close, he was also maintaining his velocity. So in a chasing state, when he gets too close, he goes to idle, so we'll do the same thing. We say stop moving, and let's see that in action. As he gets to a value of 4, there we go. Seemed quite close. I was a bit worried it wasn't going to work. Okay, but that's a world. I'll get rid of the 4. Whoa, we're running, of course. Wasn't the most clever thing to do. Let's try that again. So getting 4, and what I should have done is turn off the renderer and bring up my grid. So yeah, he's within a range of 4. But that's happened for us. That's great. Of course, I've made changes to the scene. So I'm going to save that. Then I'm going to think about what I'm going to show next.